Hello, my name is Dr. Tim Webster and I lead the Applied Geomatics Research Group at the Nova Scotia Community College. Our project is all about trying to prepare warning systems in advance of severe weather events that are being exacerbated by climate change. We've seen deaths, we've seen damage to infrastructure, we've seen destroyed houses. We have coastal flooding from hurricanes and nor'easters and erosion. We have river flooding, flash flooding. We have fire. Solution to this need is resilience. New data and risk prediction for Nova Scotia's adaptability to climate impacts. Our grand challenge here is to make Nova Scotians be more adaptable to plan for, react to, and recover from climate impacts. And to do that, we're proposing to break our project down into 4 significant pillars related to coastal flooding, river flooding, coastal erosion, forest fires, and also to supplement that information with topobathymetric LiDAR, which is a unique system to NSCC to capture elevation data not only on land but under the water for hydrodynamic modeling of rivers in the coastal zone, and something called a geoforensic team to capture details after a storm event. This basically depicts the same thing, but it's all about response and planning to make us more resilient, and it involves a variety of prediction systems and advanced modeling and geomatics data. Coastal prediction, we have developed a previous flood mapping system for 10-day storm predictions, but we only had it for a few select areas. This shows the predicted storm surge ahead of Fiona. And when we link this prediction to the map, we can see what's going to be flooded. We want to expand this to the entire province and bring everything up to date. As well, we want to use seamless elevation data to develop hydrodynamic models to link the Environment Canada course storm surge models with a higher resolution hydrodynamic model that will show us not only current velocities, duration of the storm, as well, of course, of inundation. This can also help us understand the hazard more with water level and water speed, as well as the impact of the storm on things like erosion. We can see the inundation here when over the road. River predictions, we can use weather forecasts to actually predict how the river will behave and what the flow will be. And we can then use advanced geomatics maps to then show where the area could flood for select rivers in Nova Scotia. Erosion, this is something we want to try to support the municipalities with to give them quantitative information so that they can then develop bylaws or other policy to better inform Nova Scotians where it's safe to build. We can do things like historical aerial photos to look at how the shoreline is receding and what that horizontal change, or we can use more advanced 3-dimensional mapping with LiDAR, drones, and other things to do before and after storm events to calculate the volume of change. Lastly, we can look at wildfires, and we're working with a company, an Indigenous-owned firm, 3D Wave Design, who have a fire behavior modeling software that we want to advance and input in additional forecasts to see farther out what the fires could do. This is a quick look at this idea of geoforensic mapping. On the bottom, we're showing what the predictions of Fiona were going to be without waves, and then the yellow numbers represent where we've gone out and surveyed those high water marks that include wave run-up, and we can see the erosion impact on the right-hand side. Similarly, we did the same thing after the big 2003 flood event in West Hants, where we mapped those high water events. These are important to update our return period, so how often an event will happen. To make that point, I'm showing that coastal hazard map that shows what the worst flooding in 2100 will be along the Northumberland Strait. Down below, we've simulated that same water level, and this water level turns out to only be 20 centimeters higher than what we've already seen with Fiona. The reason that this is an underestimate, our return periods are too low. We've got a great team, so we have the capacity to do this, both with internal NSCC researchers at AGR, and we have 6 university colleagues as well doing individual research projects to support it, along with NSCC IT. Federal government, provincial government scientists and experts are all there to support this project. We can't wait to get started to make Nova Scotia more resilient. Thank you.